Now, we have, for this one, we have L Hospital's lab, or Hell's Hospital's rule. So, L Hospital states that the limit, my marker's run dry, as of a certain function, so as x approaches c, of f of x over g of x, is equal to the limit as x approaches c of f prime of x over g of x, g prime of x. So we can take the derivative of both functions, and these limits will be the same. Now this helps when we have a situation like the limit as x approaches 0 of x plus, or let's say x approaches 4 of x plus 3 and x minus 4. Now if we were to use direct substitution, right, well first we have to prove it. So the limit as x approaches 4 of x plus 3 equals 7. Now the limit as x approaches 4 of x minus 4 equals 0. So that would mean the limit is 7 over 0. So now that we've shown that it's an indeterminate form, we can take the derivative of both functions, and which is the limit as x approaches 4 of 1 over 1, which is simply just going to be equal to 1. So this means that this limit is 1, and it helps us solve for when we can't just use direct substitution. Now, there are other cases in which this can be helpful. For example, let's say the limit as x approaches infinity of x squared plus 2 over x plus 1. Now, both these would go to infinity, right? So the limit as x approaches infinity of x squared plus 2 equals infinity, and the limit as x approaches infinity of x plus 1 equals infinity. We get infinity over infinity, and we can't really compute that. Now, but using L Hospital's rule, infinity, we can find the derivative, which is 2x over 1. Now, if we plug that in, that means it will just approach infinity. And that's how we can use L Hospital's rule to compute a limit that we couldn't compute through direct substitution.